Hi. So in this class of cloud computing technology, today we will study about the cloud computing virtualization. So that means we're today going to study about the concept of virtualization, that how virtualizations enable the cloud computing technique. Now, if we have studied about the various service models. Just an introductory part that we have three kind of service models here in cloud computing, starting from your infrastructure as a service to platform as a service and then software as a service. So infrastructure as a service, that means it is providing you the network infrastructure, that is the various physical machines or virtual machines. So this very part here, which is the infrastructure as a service. This service model of your cloud computing here is enabled by virtualization. So we will study here about the virtualization and then we will study that how the physical machines are migrated to this virtualized scenario. So first of all, what we have here is the concept of virtualization. So we have here virtualization. Now, virtualization is basically a technique which allows to share the single physical instance of an application among multiple tenants. It is a technique which here allows to share a single physical instance of an application, or we can say that a single physical instance can be here shared by a number of tenants. A particular resource can be shared here among multiple tenants. So in computing, in this cloud computing here, virtualization is referred as the act of creating something virtual rather than actual. Now, this virtual version can here be something like your computer hardware or your platform like your operating system, your storage device or other computing network resources. So this is a technology which can or which provides here platform to create something virtual. That means creating an instance of a particular resource. So that could be any hardware. You can create a virtual hardware instance, operating system, storage, or other computing resource. Now, when we are creating these virtual instances rather than actual, so that means they can be shared here among a number of users. That means we can create such number of multiple virtual instances and then they can be shared here among multiple tenants. So we can say that it is a technology to run multiple same or different operating systems or these resources which will be completed isolated from each other. It's simply like you are running both Windows and Linux on same system. So both of these will be isolated from each other. They will not interfere here with each other. So this virtualization here is one of the hardware reducing, cost saving and energy saving technology that is rapidly transforming the IT landscape and fundamentally changing the computing ways, because we are able to share multiple resources and we are reducing costs and hardware also. So that means this virtualization here is used in this infrastructure as a service of your cloud computing. In this particular model of your cloud computing, or we can say that this service of cloud technology here is enabled by virtualization. So this virtualization, the concept here is basically creating a virtual machine over existing operating system and hardware. That is your process of virtualization, that you have one system, that is your hardware and the operating system. Now you can create another virtual machine over that existing hardware and that system. So it is simply done by assigning a logical name to a physical resource and providing a pointer to that particular resource whenever that is required. That means for every such entity, the such virtualized entity, we just have to provide a logical name. Now, the various organizations which are using the concept, they're providing the logical names for that resources and a pointer so that the physical resource can be accessed when it is demanded. So we're saying that it is a concept of creating a virtual machine over existing operating system and the hardware. So we have here host machines and your guest machine here. Now, host machine is that machine on which the virtualization takes place, or we can say that on which your virtual machine, VM here refers to virtual machine, is created. Now, second, we have the guest machines. So, guest machines are the virtual machines which run over the host machine. So, these are basically your virtual machines here. Now, this virtualization is enabled or this is managed by a software which is called a software or a firmware which is referred as your hypervisor. So, but if you just compare the systems before virtualization and after virtualization, so there is a great difference here. Like this. So, now, if the virtualization is not used, you're not using virtualization, so what you will have? You will have one operating system over that one machine. Now, software will be installed or whatever the applications you will be using on this operating system here. So that means the software and hardware here are tightly coupled with each other. So that means it is running multiple applications on the same machine and it can often create conflicts between those applications. So here is one system. This is the hardware for your one system. Now it has this operating system and it has a number of applications. Now, if virtualization is enabled, what you will have? You can have here multiple operating systems over one machine. So that means hardware, or you can say the software and hardware are not coupled, they're independent of operating systems and the various applications. How? Because if you have here the simple this architecture and this is your host operating system here. Now, what will happen? Virtualization is enabled, so you will have here this virtualization layer here. Now this will allow here a multiple instance of the operating systems like this. Now each of these operating systems can have the different applications and they are isolated from each other. So that means you just don't have to have a different hardware for each of these operating systems. So that's why we can say that it's in hardware reducing and cost saving technology. And it helps to build the infrastructure of a cloud computing system here. So here that means we have this hypervisor layer. It's a software layer which enables this virtualization technology. So before that, uh, once again, virtual machine. So virtual machine is basically a software computer that acts like a physical computer on your existing system here. Now, hypervisor. So your hypervisor here is So we say that this virtual machines which are created here, they will be managed by the hypervisor. So this is basically a software layer between the hardware and the operating system, which will interact with the hardware and the resources and provide an interface to share those resources. So this is basically a layer between your hardware and the operating system. So basically it is interacting here with the hardware and the resources, so that the resources here can be provided to the various instances or various virtual machines which have been enabled on your system. Now this hypervisor is also categorized into two categories here. One is your bare metal hypervisor and another one is your hosted one. This is bare metal and another one is the hosted. Now what happens in bare metal? Because simply hardware. After your hardware, what you will have the hypervisor layer here. That means you don't have any host operating system. After that, you can have here like virtual machine 1, virtual machine 2, or your another virtual machine here. So this is your bare metal. That means hypervisor is directly here installed after your hardware architecture. That means you will have simply your hardware, then your VM virtualization layer, and the various operating systems, or we can say that the various virtual machines here. So examples for like your this bare metal are like RTS hypervisor. So this is just selected according to the requirements here, or Oracle VM. Now after that we have the hosted one. Now what happens in the hosted one? You basically have an host operating system. That means if this is your hardware architecture, then to this hardware architecture you have your CPU, your memory, your network interface cards, and various hard drive and hard disk. After that, what you will have here now, you will have a host operating system. That's not working here. You have this host operating system. Now, after the host operating system, what you will have the virtualization layer. Now, after that virtualization layer, you will have the various guest operating systems or your virtual machine. So this is the difference between a bare metal and the hosted hypervisor, that it doesn't have any host operating system and it has here an host operating system. So examples for your hosted one are like your Microsoft Hyper-V, VMware Fusion, etc. Like your Microsoft Hyper-V here. Now, so this was about like virtualization, how the virtual machines are managed. They're managed here by this hypervisor. That means this virtualization layer here would enable the concept of virtualization, or we can say that the various virtual machines will be created when this software layer is installed between the hardware and the operating system. Now, we have different categories of your virtualizations here. So if we're just talking here that about that this infrastructure as a service here is mainly enabled by virtualization. So we have here, first of all, if we say about hardware virtualization, so your hardware virtualization will basically refers to the creation of various virtual machines, or refers to the creation of virtual machines that act like a real computer with an operating system. So software which is executed on this virtual machine is separated from the underlying hardware resources. So basically what we're just going to discuss here is the kind of virtualizations here. So we have full virtualization, emulation virtualization, and para virtualization. So first of all, we have full virtualization here. Now, what happens in full virtualization is that the underlying hardware is completely simulated with your guest system. So that means the guest software doesn't require any modifications to run. So what basically full virtualization requires that every salient feature of your hardware should be reflected into your virtual machine. That means you have one piece of hardware on which we're going to create another multiple instances. So the various salient the features of this hardware should reflect in the various virtual machines which are created. That's why we're saying that in full virtualization, underlying hardware is completely simulated. Whatever the guest software you're running, they just don't require any modifications to run there. So that is a completely or full virtualized system because whatever instances are creating, they're carrying here the properties of your hardware there. So if this is a system, for example, this is type 1 and you have here the hypervisor, then you will have host, and if this is the guest. So what will happen? You will have at this stage, you will simply have here the guest machines here, and here you will have a VM, your virtual machine control here, and a virtualized environment here. Basically, like having the kernels here. Now, this is here interacting with this like this. So here, complete hardware is simulated. So these kernels are basically the computer program that constitute the central core of this computer's operating system. So it has the complete control over everything that will occur. So that means you have your CPU, memory, then the kernel, and then you have the your application. So this is the central core of your operating system, this part. So after this full virtualization, that means where each feature of the hardware is reflected in these machines. After full virtualization, you have emulation virtualization. Now, here the virtual machine simulates the hardware. Here, the virtual machine will simulate the hardware. That means it is independent of it. So what happens in your emulation virtualization? This is simply making one system imitate the other system. For example, if we have if a piece of software runs, we have a software XYZ. So this piece of software here is running on system A but not on system B. So what we can do, we can make this instance B here to emulate the working of A. So it will emulate here the working of system A. So this is your emulation virtualization, in which the virtual machines basically simulates this hardware. They are independent of it. We're just simply making here one system imitating the other system here. Now after emulation virtualization, the last one is your para virtualization. Para-virtualization. So what happens in para-virtualization is that hardware is not simulated. The guest software runs their own isolated domains. Here the hardware is not simulated. Hardware is not simulated. That means this para-virtualization is an enhanced version of this simple virtualization. Here what happens is it provides a software interface to the virtual machines that is similar but identical from the underlying hardware. That means the guest machines here are provided with the certain software interfaces so that they can run their isolated domain over there. That means if this is your system here like this, you will have your system hardware like this. Then you have your host and then the guest. So you have here simply your VM control, VM kernels here, and if you have here your guest systems here, so you will have with these systems the virtualization environment and the software so that the independent domains here can be run by these various virtual machines. So this is para virtualization. So here we just have started the virtualization concept in your cloud computing, that what virtualization is and what are the different types of virtualization, like full virtualization, emulation virtualization, and your para virtualization here. So this is all for today's class. We will continue more about virtualization in our upcoming sessions. Thank you so much.